Hello, my name is Katerina Shevchenko, aka Morningstar, and welcome to 23rd day of Advent of Cyber by TryHackMe. I'm super excited to be a part of this year's lineup. If you are new here, let me briefly introduce you to the Advent of Cyber. Throughout December, TryHackMe releases a new beginner-friendly challenge every day, helping you learn, solve puzzles, and stay one step ahead of King Malheur. With over $150,000 in prizes, it's an awesome way to pick up new skills while enjoying festive season. Every task you complete increases your chances of winning. The more challenges you solve and questions you answer, the higher your odds. And if you haven't started yet, now it's a perfect time to jump in. You can still catch up on earlier rooms and they cover some interesting topics. So with that, let's dive into day 23. Today's challenge is called AWS Security Secret Santa, and there is even a small hint in the name about what we'll be working with today. But let's start with our storyline. A stealthy elf made it into office of S3cret Bane and found cloud credentials sitting on his desktop. This might help us regain access to cloud network of the best festival company. The hair has no clue what cloud is, so let's take over from here. And by completing this room, we will learn the basics of AWS account, enumerate privileges from attacker's perspective, and get familiar with AWS command line interface. And let's review the connection card. For this room, we will need attacker box, only virtual machine that we can run by pressing this Start Machine button. It will be ready shortly. Right now, VM's open in split view, but we can switch it to full screen mode by clicking this button. And now our machine in separate tab, so we can close the split view in our Rooms tab. Alright, now we're all set. We found cloud credentials, but what exactly are they? Let's open credentials file in .aws folder and take a closer look at them. They are a pair consisting of access key ID and a secret access key, which allows access to AWS account. For this room, they're already generated and pre-configured for us. In square brackets, you can see profile name. Later, this file can contain multiple profiles, each with different set of credentials, and you can switch between them by adding flag profile and profile name to your command. But for now, we'll just use default profile and we don't need to indicate that in our commands. Let's get information about this user by calling command close analog of who am I in AWS. AWS STS get color identity. Let's take a closer look at syntax. Every AWS CLI command follows same structure: AWS, service, and command. So in this command, STS is a service you're interacting with, and get color identity is a specific action or command you want the service to run. And let's briefly talk about this service in particular. AWS Security Token Service, or STS, is a service provided by AWS to grant temporary limited privilege credentials for accessing AWS resources. So by running STS get color identity, we can get information on user we got credentials in our default profile. So here we have user ID, ID of account, and IRN, or Amazon resource name, which serves as unique identifier of specific AWS resource. In this case, it is identifier for user S3cret Bane. And now we have answer for the first question of the room. What is the number shown for account parameter? So we can just simply copy the account ID from command output and paste it into answers field. And first question solved. Good job. Now, let's learn about another important service of AWS called IAM, Identity and Access Management. IAM helps you control who can access resources and what actions they can perform. And because it manages permissions, any misconfiguration can lead to serious security issues. Now, let's briefly look at different aspects of IAM. In AWS, a user is a single identity with its own credentials. You can give each user specific permissions that decide what this user can and cannot do in account. But in real organization, you wouldn't configure permissions for every developer or every accountant. That's where groups are useful. A group lets you organize multiple users and set permissions to all of them at once. And if user no longer needs access, you can simply remove them from the group. A role is a temporary identity that users, services, or even external accounts can assume to gain specific permissions. Instead of permanently assigning privileges to a user, a role lets them take on only access they need for a particular task. And last but not least, we have policies. Policies control access granted to user, group, or role. And let's take a look at the example from the room. Here we have policy ID, allows specific user read access, followed by effect. In this case, allow means that action is permitted. The principal field tells us who this rule applies to, and the action field defines what is allowed. Here, S3cret object. And resource field specifies which AWS resources this permission applies to. So basically, this policy grants access to AWS user Alice principal to get an object from S3 bucket action for the S3 bucket named my private bucket resource. And now we learn that policy is used to describe the permissions to be assigned to a user or group, and we can put it as an answer. And now let's switch to practice and see what we can do with our credentials. We start by enumerating the IAM components we discussed earlier. Begin with users. With command AWS IAM list users, we can get a list of users in this account. Luckily, almost all commands in AWS CLI are straightforward. But it seems like we have only STS user for now, and we got information on this user from output. Let's also check if STS belongs to any group. We can do it with command AWS IAM list groups for user, username, STS, where we're looking for groups that specific user belongs to. But looks like STS is not a part of any group. We also discussed policies, so let's also enumerate them. We have two types of policies. Attached policies are shared policy documents that can be shared between multiple users, groups, or roles. Inline policies are written directly inside of specific user, role, or group, and because they are tied to this specific identity, they disappear if that identity is deleted. You can think of them as a hard-coded permissions. Let's see what attached policies are assigned to STS by running this command. AWS IAM list attached user policies username STS. Not much here. Maybe we'll have a better luck with inline policies. We'll use command to enumerate them. AWS IAM list user policies username STS. Great, we can see the inline policy in results. Let's check what this policy contains by running command AWS IAM get user policy, policy name, STR policy, it's case sensitive, and username, STR. This policy allows the user to enumerate wide range of IAM entities, like users, groups, roles, policies, and so on. But one permission stands out: STS AssumeRole. This one might be important. But before we continue, let's answer the next question in the room. What is the name of policy assigned to STR? Let's copy from the output. And the answer is STR policy. And now we can return to our finding. STS action allows STR to assume roles. So the question is, what roles exist in this account? We can enumerate them with AWS IAM list roles. So we can see a single role here called bucket master. And we are extremely lucky because role trust policy allows STR to assume it. Remember, assuming a role always requires two conditions. The user must have permission to call AssumeRole on this role, or wildcard like in our case, and role must have this identity in its trust policy. In this case, both requirements are met, so we can successfully assume the role. Let's check what we can do with this role by reviewing its policies. Just as users, roles can have inline and attached policies. We can check attached policies with command AWS IAM list attached role policies, role name, bucket master, which is very similar to that one we were using for user. Nothing there, so we can check the inline with command AWS IAM list role policies, role name, bucket master. So there is one policy assigned to this role. Let's check the content of bucket master policy. AWS IAM get role policy, role name, bucket master, and policy name, bucket master policy, also case sensitive. Based on this policy, bucket master role can perform different actions on some resources of service named S3. But before we will discuss this service, let's assume role so we can try these permissions in practice. For assuming role, we will need command of STS service, AWS, STS AssumeRole, role IRN, value we can get from results of list role command, just copy and paste it, and role session name, which can be any value. I will just use short version of STR-bucket master. In results, we can see another type of credentials. In this case, we also have session token, without which access key ID and secret access key won't work. We can export our credentials in our session by using command export and variables in such syntax: export AWS access key ID, and just copy from the output, paste it. Next is export AWS secret access key, Again, just copy and paste it. Next is export AWS session token and copy this whole line. Make sure to copy everything and paste it. And now let's check that everything is correct with get color identity command. Now we can see that we successfully assumed role of bucket master. And if you don't see such output, check if you copied your new credentials correctly and try to export them again. Before we continue, we need to understand what S3 actually is. Amazon S3 or Simple Storage Service is AWS Object Storage Service. It is used to store files of any type: images, documents, logs, backups, and more. These files are called objects and they are stored inside of buckets, which you can think of as cloud folders. And now let's see what we can do with our role. S3 list all my buckets allows you to see the list of S3 buckets inside of AWS account. Only the list of buckets, not the content of them. And S3 list bucket allows you to view the contents of specific bucket. And S3 get object allows you to download or read specific object from a bucket. And now we can answer a question from room. Apart from get object and list bucket, what other action can be taken by assuming bucket master role? So here is, we'll just copy, list my buckets. So now let's enumerate the S3 service. We can list available S3 buckets with command AWS S3 API list buckets. Here we have two buckets. One is Bunny website and another is the secrets. So let's check the content of bucket that references Easter with command AWS S3 API list objects bucket, and we'll just copy the name of the bucket. Here we have two files, groceries.txt and cloudpassword.txt. And this file definitely catches the attention. Let's download it on our machine. AWS S3 API get object bucket, just again paste the name of the bucket, key, that would be a file name, cloudpassword.txt, and we'll just reuse cloud password as a name for our local file. And we successfully downloaded. Let's check it in our files. And let's read it. So here we have a flag for our room. And that's how we successfully infiltrated STS S3 bucket and exfiltrated sensitive data. Good job! And that's everything for day 23. We walked through how to enumerate permissions, assume a role, explore S3 buckets, and discover sensitive data stored in cloud. This challenge is a great example of how attackers can take advantage of misconfigurations in permissions and how important least privilege and proper access controls really are. I hope this video made the concept easier to understand, especially if you're just starting in cloud security. If you found this helpful, consider supporting the video with like, comment, or subscribing. It means a lot. Thank you so much for joining me today, and enjoy the rest of Advent of Cyber. See you in the next one.